Okay, boys and girls, today I'm recording our math lesson.
Cool. Good for
Okay,
you.
so if you want to say hi,
Hi,
you can.
Mom.
Hi, Ryan's mom. All right, so I have worksheets around the classroom. Jackson, will you please sit down?
Why?
Because we're gonna work on math. That's why.
I want to be in the camera.
Well, you can sit over here so you can be in it. Okay, Jackson.
I want to be in it.
Then you can sit over there if you want to be in it.
here.
Yeah, sure.
I'm
Okay,
in.
I'm turning it off.
Hey!
That's okay. So obviously we can't handle it if we can't pay attention to math. Okay, so, Kamara, do you have a worksheet?
You just turned the light down.
Because we're going to be, Jackson, you weren't here yesterday, so we're going to be working with fractions today. Okay?
Oh, I know the first answer.
All right, well, let's read the problem together, okay? It says,
Blah, 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 blah.
Count the
close,
number.
you're really close. Okay, it says, the shaded part of the circle represents the part of a day that Ariel spent sleeping. What fraction of the day does Ariel sleep? So, for step one, we're going to count the number of equal parts in the whole. So, Ryan, how many equal parts are in this whole?
1/3.
Well, how many parts? So there's
Oh.
1, 2,
3.
there's going to be 3 equal parts right here. Okay? And the denominator is 3. Jackson, what's the denominator?
Huh?
What's the denominator?
1/3.
What's the
No.
denominator?
What the denominator?
It's right here. I need you to follow along, okay?
3.
3. Fantastic. So step 2 is count the number of shaded parts in the whole. The whole has 1 shaded part. The numerator is 1. We read the fraction for the shaded part as 1/3. So on here, just going to shade it in there so you can see it more. So then we're going to go down. So right here, it says, so Ariel slept for blank of the day. Kamora,
1/3.
1/3. And how do you know that?
Because in the picture, there's one shaded and then the two are left out, and then all there's 3.
Yes, exactly.
Oh.
Yes, please. I'm sorry. There was pencils out on the tables. Okay, so, Jackson, what does this circle represent? What does this entire circle represent? You want to phone a friend?
Yeah.
Okay, Kamara, what does the entire circle represent?
How long Ariel's for?
Well, that's what the shaded region represents, but what does
How
the
many
entire
whole
day?
numbers?
What does the entire circle represent? It was in the directions that I read.
Equal parts.
Equal parts of what? Of a day. And the shaded part of the circle represents the parts Ariel spent sleeping. Okay? So 1 whole circle equals a day. Okay, so equals a day. What then?
Is this still recording?
Well, we're gonna. No, it's not recording anymore. We're gonna start working with the magnets soon, okay?
You said we weren't.
Huh?
I thought you said we weren't.
I know, but you couldn't handle it. So, how do you find the denominator in this situation? How did we find the denominator? More? Yeah?
By looking at the
By looking at the.
fraction.
So, how many fractions this circle was broken into? Yeah, correct. Good job. So, how many parts? Okay, and so how do we find the numerator, Ryan?
We see like how much number up.
Yeah, so, but how did we find the numerator of this one?
Because it's one whole thing and it's a day.
Well, I think you're thinking too much, bud. So the whole has 1 shaded part.
No.
The numerator is 1.
Is it how parts?
So how many shaded parts? Okay, can I get a thumbs up if that makes sense? Thumbs to the side if it kind of makes sense,
What's the
or
side
thumbs
of
sides to no.
How parts?
Huh?
How?
Oh, how many? I forgot to write many. It doesn't make sense to you? Okay, so here. I have these. Okay? So each one of these sections is labeled 1/3, similar to this, okay? So this circle equals an entire day, just like Ariel's day. So say, Ryan, you spent an entire third of your day eating. Okay? Eat pizza and stuff, okay?
Yeah.
So how would you be able to tell which one or how much of the day you spent eating? It would be
1/3.
1/3. So what they did here is like this. So they took a circle and just pretend this makes sense. Okay? So 1/3 you spent eating, and the other 2/3 you did not.
Yeah.
But your day is broken into 3s. Jackson? Thank you. So what it's saying is the numerator is the shaded part, which is the third or this third. So the numerator is the shaded
Shaded part.
part of the whole for this problem. Okay? Alright, so
Will we get a move amendments and stuff?
yep, I just wanted to show you this first problem. Okay?
Of
So now
what?
it's gonna be you guys are up here and kind of
Of the half.
of the whole. Shaded part of the whole.
Shaded part of the whole.
Mm-hmm. Okay. Alright, on to page 2. Jackson, you have that written down?
Yeah.
Okay.
Next page.
Next page. Alrighty. Friends. So, let's read the problem.
Muffin.
Alright, on 2, I want you to read the problem with me, okay? 1, 2. Billy rode his bike 3 times around the park to complete a total of 1 mile. How many times did Billy ride around the park to complete 2/3 mile?
What's 2/3?
What do you mean, what's 2/3? They're asking you.
Oh, 2 whole.
No, well, let's look at it. So step 1, we're going to use a fraction strip for thirds to divide the number line into 3 equal parts. So, Ryan, here are your 3 equal parts. Can you form them into a number line for us? Can you put them close together though? Awesome. Okay. So on here, here's our number line. So here's 1/3, here's 1/3, here's 1/3, okay? So 1, 2, 3, okay? So this is exactly what they did. So label each mark on the number line. Well, we already did that, that's okay. So it says draw a point on the number line to show 2/3 of a mile. Okay, Kamara, where's it gonna be?
Wait, can I go back now?
Oh yes, go ahead. Ryan, where's 2/3 of a mile going to be on the number line? Just draw a little dot, like on the line. Yeah, oh, you can color it in. Sorry, buddy.
What do you mean?
So make a big dot, like how you can see theirs. Make it so you can see it.
Maybe we
Good.
can use other color.
Yeah, we'll use another color next time. Okay, Jackson. So, Billy rode his bike around the park how many times to complete 2/3 of a mile? If our number line equals 1 mile, okay? How many times is 1 lap around the park? If it says Billy rode his bike 3 times around the park to complete a total of 1 mile. Where'd you get that number at, bud? Do you think you're giving me your best effort right now? Can you help? And
Yeah.
you think so? Okay. So
I have no idea.
Okay, thank you for being honest. I appreciate that. Okay, so we have 1/3 of a mile, 1/3 of a mile, 1/3 of a mile. What they're saying is 1 lap around the park is equal to 1/3 of a mile. Okay?
You might want to put your line a little bit farther from the looks of the line.
Oh yeah, you're right. 1/3 of a mile, okay? So, Jackson, if we want to find how many times he rode around the park to make 2/3 of a mile, what are we going to do? Are we going to add or are we going to subtract?
Add.
Exactly. And what are we going to add together?
2/3 and 1/3.
Close. How about 1/3 and 1/3? Because each 1/3 is 1 lap around the park.
I think it's 2/3.
So 2/3. This equals how many laps? No, this fraction. How many laps?
1/3.
1 lap. And Ryan, how many does this equal?
1 lap.
1 lap. So how many laps did he do in total to equal 2/3 mile?
2 laps.
2 laps. Jackson, does that make sense?
Yeah.
Okay, so can we write this down? So Billy rode his bike around the park how many times, Jackson?
2 times.
2 times to complete 2/3 of a mile.
Those magnets feel good.
I know. I like them. They're kind of fun. So, on this one, why do you divide the number line into 3 equal parts?
Because he rode his, he rode 3 laps around the park.
Exactly. Yeah, so just write that down, okay? So it's because he rode his bike. Jackson, are you writing it down? 3 times around
He rode his bike.
the park. Perfect.
Next question.
No, wait, I'm just gonna let wait for Jackson.
Around
Around the park. Okay, so what is the distance between the markings on the number line? Ryan? What's the markings? What's the distance?
1/3
1/3 of.
of the line.
Good job. Awesome.
I wish I could be the principal for today because a kid in 5th
Oh, I
grade.
did see that. I
Yeah.
did see somebody was the principal for the day. Well, maybe you could be. Okay.
Yeah.
So, explain how you know the number of times Billy rode around the park to complete 2/3 of a mile. We've already gone over this, Jackson. So, we've already gone over this one. Hi, Elise.
That's
Evelyn.
I'm sorry, the other one is Elise. My apologies. We are actually doing a different worksheet than that one. Do you want to do the same worksheet as us? I have an extra copy.
Quite easy. I'll do it. Yeah.
Okay. One second.
She was gonna film us.
I was going to film you until you couldn't handle it.
Oh, duh, I wasn't.
All right, so we're on this one right here, okay? So far, we're trying to figure out, so I'll read the question to you. Billy rode his bike 3 times around the park to complete a total of 1 mile. How many times did Billy ride around the park to complete 2/3 of a mile? Okay? So, we've already decided that Billy rode his bike around the park 2 times to complete 2/3 of a mile. And from our little number line down here, we decided that 1 lap around the park is equal to 1/3 of a mile. Okay? give you a little bit of time to catch up, okay?
More than that in one time.
No, it hasn't been that long, I don't think. Girls. So, everyone, are you close? There she is.
Okay.
Do
Alrighty.
you guys do this every day?
Yeah.
We don't do this.
We don't do this exact
I don't
sheet
think
every
you're
day.
here every day though. Aren't you here every day or no?
3 times a week. So, alright, Ryan.
Yeah.
So instead of doodling on the bottom of your paper, will you read number 3 for us?
Explain how you know the number of times Billy rode around the park to complete 2 thirds.
So how do you know? You want to answer that question for us in other words?
I don't get the question.
So what it's asking you is, how do you know the number of times Billy rode around the park to complete 2/3 of a mile? Remember? So we're going to use this rule that we just came up with. 1/3 of a mile is equal to 1 lap around the park. Okay? So how do you know the number of times Billy rode around the park? Did we add them? Did we subtract
We
them?
added.
We added 2 laps.
Yeah.
We added 2 1/3s together. Okay?
Added?
Mm-hmm.
Are those 8s?
Those are
Where are those like right next to added?
yeah, no, I didn't show up very well.
Added 1/3.
Okay. Do you have it written down, Jackson?
What is that word? Together?
Yep.
1 lap
Together.
equals 3.
1 lap equals 1/3.
Together because
Equals.
because
Because 1 lap equals 1/3 of a mile.
Look how big this eraser is.
That's a brand new pencil, I can tell. Okay.
I can't see. Oh, because
Oopsie. Guess what?
Right.
All week my babysitter's taking care of me because my mom and dad are in Mexico.
Oh, well, that's nice of her. Okay, just a couple more seconds, Jackson. And then on the next one.
equals
1/3 of a mile. Hey, Ryan.
Yes.
Checking to make sure you're still kicking. All right, on 1, 2, or on 2, we're gonna read the directions together. Okay, 1, 2. Alex had 12 toy cars. He gave 1/3 of the toy cars to Patrick. How many toy cars did Alex give to Patrick? So, let's look through the steps that they give us. Okay. Evelyn, can you read step 1?
Yep. Look at the denominator for the fraction you need to find. You want to find 1/3 of the group, so make 3 equal groups. Draw 12 squares to show the 12 cars.
Okay, Jackson, so instead of drawing the 12 squares, I have 12 square magnets.
Ooh.
Okay, so I want you to arrange them similar like this, Jackson. Come up here and do it. You're messing with your shorts. So it says, so make 3 equal groups, draw 12 squares to show the 12 cars. But instead of 12 squares, we're just going to arrange those little fractions, okay? So just stick them up there in 3 equal groups. You can do that if you'd like.
getting mud out of your shoes.
Ryan, bud. Come on.
Me?
Yep. It's taking a long time there, bud.
Hey,
I know.
that's my job.
Well, if I would have wanted a snail, I would have called on that instead. I'm just kidding. Alrighty, so Jackson has now arranged almost perfectly and precisely our 12 squares to show 12 different cars. Does anybody know why I have the squares labeled as 1/12? Ryan?
Because see, there's 12 blocks in here, and they're each equal to 1 block.
Good job, buddy. Okay, so now it says to circle one group to show 1/3. Kamora, you want to come up here and circle one group to show 1/3 of the cars.
Oh,
Don't go slow, please. You're an awful influence sometimes.
why? Yay.
So I circle one.
Yep, just circle one group to show 1/3.
Even slower.
So when I mean one group, 1/3 of the entire whole. So all 12 of these are all of the cars that Alex has. He's going to give away 1/3 to Patrick. Okay? So these are broken into thirds, right?
Yeah.
Okay, so circle 1/3 of the group. Or one equal. Yep,
Those look like marshmallows.
I thought that too. Okay, perfect. Thank you. So now let's count the squares in the circle of the equal group. So, Evelyn, how many squares or how many 12ths are in this group? 1, 2, 3, 4. So there's 4 12ths, okay? So 4 12ths is also equal to 1/3 of the group, okay? So Alex gave blank toy cars to Patrick. So how many cars did Alex give to Patrick?
1/3.
1/3, but how many cars exactly?
4.
And how do you know that, Jackson?
Because we just said 4 12s.
Wait.
Yeah.
But these, why wouldn't the answer be? Because 12.
Because he started out with 12 cars, and so he broke the 12 cars. Each one of these is one car. So he gave 1/3 of them to Patrick. So we divided them into 3 groups. So he gave 1/3. So he gave one whole group to Patrick. Does that make sense?
Yeah.
So he gave 1, 2, 3, 4 cars to Patrick, or 1/3 of all of his cars. Yes?
Yep.
Okay. So how many cars, Jackson?
4.
Okay. Can you write it down for me, please? So, Kamora, for number 1, why did you draw 12 squares, or why did we use 12 squares?
To show how much cars he had.
Yeah, exactly, to show how many cars he started out with. So, to show how many cars he had. Okay? Cars he had. So Ryan, for number 2, why do you put equal numbers of squares into each group?
Because there's
But why do we have to?
because the show
To show what? You're right. You're on the right track, buddy.
to show us how many 12
So to show how many cars there are, because he gave 1/3 of the toy cars to Patrick. So we have to divide them into thirds. Okay, so why did we put equal numbers of squares into each group?
I have to go get this one.
Okay.
Because
Because he gave him a third.
What's the answer?
Because Alex gave him 1/3 of his cars.
Because Alex
Gave
gave
him
him
1/3 of his cards. Ryan, you just got this. Okay, so for number 3, why is your answer less than the total number of cars? Kamora, why do you think the answer is less than the total number of cars?
Because when you circle the line thing, there's only 4
Mm-hmm.
in the line.
So, in the question, did it say that Alex gave all of his cars to Patrick?
No.
No. And if we only have this many cars to give to Patrick, technically, can we have more than 12 cars to give to Patrick?
No.
No. So that's why is your answer less than the total number of cars is because he only gave Patrick 1/3 of his cars. Okay?
let's see.
What?
Let's
So
see.
Alex only gave 1/3 of his cars.
Gave 1/3.
Of his cars. Right. Buddy, I am not getting the best from you today, am I? Is there something we can do to improve that for tomorrow?
Help me, am I doing a bad job?
Mm-hmm.
I'm doing an excellent. My doing a good
Focus, yes,
job.
I like it. Okay,
My doing
so
I wish I could come in here every day.
you might be able to. All right, so I tricked you guys. It was recording the entire time.
I knew it.
So say hi.
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 Hi, Jigglebug.
Okay.
I knew it. Hello.
Hello. Okay. Well, you guys did okay today. So